Hello, in this video I decided to record the explanation of the insertion sort. So insertion sort is one of the trivial algorithms, and I think the main part of it is that it's really good on small inputs and not really efficient for larger inputs. And the algorithm itself is pretty straightforward and easy. So this is the structogram of it, kind of, and I will also show you one example on paper, and also the implementation of insertion sort in Python. Okay, so here you can see the step-by-step run of the algorithm, but I will also show it on another example. And one important note is that duplications are allowed. For example, here we have 2 and 2 prime. Okay, and here you can see the efficiency of the algorithm. And as you can see, if we have like 1000 elements, then it will take a very small amount of time to compute to sort the array. However, if you have 10 to the power of 9, then it's gonna take us 95 years. So it's really expensive. There are more algorithms which are like much more efficient for sorting, but insertion sort is also has its own advantages for small inputs. And let's just go further to the run of the algorithm here, and also the implementation in Python. So this function is exactly the same as the structogram that I presented like a few minutes ago from lecture notes. This is the same, so you can always refer to this algorithm if anything is not clear. Okay, but I will show you the run in here. So insertion sort has passes or kind of runs of the algorithm. And also one note or remark here will be these vertical bars. We will use them to separate the sorted and unsorted part of the array. So basically our input is the following, and as you can see here we have duplicate elements 2 and 2 prime, and we will just use this bar, this small prime sign to differentiate them. Okay, so we start from the first element, and since a single element is already sorted, our separated bar, I will just cross it like this when we do not need any swappings of elements. And then we go to the next element, which is 6. And here I divided it with this vertical bar. And what we do is we take this element and we compare it with the previous element. So 6 is bigger than 4, which means that it's already sorted and we do not need to change the places of elements. That's why I will also cross this vertical bar and put the next vertical bar here. And the next element is going to be 2 prime. And we take this 2 prime and we compare it with the previous element, which is 6. And 2 prime is smaller than 6. That's why we need to save this element in a temporary variable. So if we go back to the code, then we have this condition that if the previous element is bigger than the current element, then we need to save this variable. And also one note is that we start this algorithm not from the zeros element, but from the first. So we save this 2 prime into x, and then we do the same thing. We compare it with 6, and after that we put in a place of the current element, which is 2 prime, the previous element of the array. So that means that as soon as we save this 2 into x, we will put this 6 into the place of 2. So we will shift 6. And then we'll compare 2 with the previous element of 6, which is 4. And we see that 2 is smaller than 4. And then if you go to the code, we need this index j, which will basically be needed to in shifting. So we did the steps so far. So now ai is equal to 6. And here I is equal to 1. That's why j is going to be -1, right? And we have -1, and we go to the next instructions, and we see that there is a condition that j should be bigger or equal to 0, and our j absolutely does not satisfy this condition. That's why we will not enter this loop, but we will go further, and here we will say a -1 plus 1 is equal to x, and x in this case is 2. So zeroth element of the array is going to be 2. And here, as you can see, we put x to here. So we're good. And we're going to do the second pass. And we put our vertical bar here first. And then we compare 8 with 6, but we see that 6 is smaller and 8 is bigger, so it's already sorted. That's why I will cross this like this and go to the next element and put a bar. And the next element is 5. And we compare these two, and we see that 5 is smaller, which means that we are going to save this in a temporary variable x. So we save it. After we shift 8 to the place of 5, and then we compare 5 with 6, and still 5 is smaller. That's why we will need to shift this to the right. And then we compare 5 with 4, but 4 is smaller, so we put 5 here. So we put 5 here, and this part is kind of already sorted. And we put our vertical bar, but it's the end of the input. And we compare 2 with 8, and we see 2 is smaller, so we save it into variable 2, and we basically repeat the same procedure. Here I describe it, the last insertion, more in detail, so you can also see this. And this is the code, and this is the input, and let's run this code and see it's going to work. So as you can see, there are some extra printings that you can actually ignore. So the result is going to be 2, 2, 4, 5, 6, 8, and it's sorted. So our code is working. That was all about insertion sort.